Let me first introduce myself. My name is Esther. I hope you jail vet. I am a simple girl with a stable background and family. I don't want to fancy me for crazy, freaky stuff. Since came to things, I'm just trying to keep it real, baby. Oh, I wanna and I'm gonna touch the sky with this music. I will make you fly, leaving you high. Oh,
I will pick some topics. There are so many topics, more than 40, which you can use to teach in trigonometry and geometry. But I will only take 2 important topics here. By the time the CD comes out, if I give it to you, you will see how I handle the other topics in other schools. So I will handle here similar triangle, exterior angle of a triangle, similar triangle, and the sector of a circle. These are the 3 things I will handle. And they are in senior, for senior classes. So I will first of all introduce the teacher set. This is the teacher set. What you have is the student set. Everything here is in that one. What do you observe there? Look at them very well. There are shapes there. What shape do you observe here? There's a gadget, protractor. Very good. It's a protractor. The protractor is a semicircle. It is half of a circle. It is a sector. They are all encompassing. Depends on what you have in mind. Good. What else do you see here and here? What else do you see here? Rectangular shape. So this is a rectangle. What shape do you see again? A square. Good. This is a square. This is a square. I see this is a ruler. This is another ruler. This is another ruler. This is another ruler. So geometric is a protractor on a plane surface bounded by 4 rulers. And there are 2 other rulers which move about. You can stick at end and displace. Now bring out your 2 rulers. They are small. Smooth. Okay. So when you want to put it together, please, this is how you hold it. You want to put it together, you bring it together. This way, this way. It's not a bigger ruler. Huh? You can now pin it, say at end. Anywhere, there's a handbook that will be telling you what to do. If you say you should put it at end, you pin it at end. And displace. Like this. You can use it to get any triangle you want. If it's equilateral, if it is isosceles, if it is scalene. But you don't have to hold it like this. I'm holding like this to show you. It will be on your table. You look at this board and do yours. So I want you to use this to form equilateral triangle. 10, 20. Equilateral. 10, 20. It's not at 30. My own is it at 20 or at 30? Yes. I want us to see this line is parallel to this line. This line is transversal. This line is transversal. This angle is equal to this angle. Who will tell me the reason? This is parallel to this. This is transversal. This is transversal. This angle is it. Oh, let me use my marker. This angle A is equal to this angle A. Who can tell me the reason? Okay. So you have not had transversal. Have you heard of transversal before? Yes. Transversal divides parallel lines, and the angles, there are angles that are corresponding. There are some that are alternate. There are some that are vertically opposite. So which one of these reasons? You did it in your junior, you have forgotten. This angle is equal to this angle. What reason? Yes? Corresponding angles. Good. Corresponding angles. This angle and this angle. Are they equal? Yes. Yes. What reason? Yes. Huh? Alternate angles. Alternate angles. Alternate angles. Then this one is 90. This one is 90. What reason? This is parallel to this. This time, this one is transversal. This one is transversal. This angle is equal to this angle. What reason? Yes? They are not angle triangle, but is it transversal? Is it corresponding? Is it vertically opposite? Yes? Huh?
Correct corresponding.
Very good. Corresponding angles. They are corresponding angles. That is the theorem we want to verify. That exterior angle of a triangle is equal to sum of two interior opposite angles. 10, 20, 30. I know I asked you to make it to pass through 30 degrees. 0, 10, 20, 30. Does it touch this line?
No.
I know it will not touch in your own because we were trying to limit space in the construction. We reduce the length here. So if it does not pass here, let's make your own 35 degrees. Shift it a little bit. So put it at 35 degrees. This is a triangle. WNP. WNP is a triangle. If you produce this line, if you extend this line, that's produce. In mathematics, extension of line is called producing the line. If you produce this line, this becomes the exterior angle to this triangle. That's one thing you have to understand. You have to understand which one is exterior angle and why is it exterior. When you produce this line in a triangle, this is exterior angle. If you produce this line in this triangle, now this is the exterior angle. If you produce which other part, this one is produced. You produce this line, this is the exterior angle. This one, if you produce it, this one becomes the exterior angle. This one now is produced this way. So this one becomes the exterior angle. So the exterior angle of a triangle is equal to sum of two interior opposite angles. It's a theorem that is in your textbook that I want you to see practically. Yes. This is 90, this is 90. And they are equal because they are corresponding angles. This angle is equal to this angle. This angle is equal to this angle. Why? Alternate angles. Now this is 90, this is 90. If this your own is what degree here? From here to here. How many degrees? 35
degrees.
Add it to 90. What will it give you?
125 degrees.
125. 125 degrees. But you have said that here is this way, they are equal because they are alternate angles. So this is equally 35 degrees. And this is 90 degrees. So 90 plus 35 gives you
125.
Then 35 plus 90 gives you 125. Here is 125, here and here, 125. Verifying the theorem that exterior angle of a triangle is equal to sum of two interior opposite angles. It's not only by cramming, you will see it on this board. I will go into another one. When I said I will touch the exterior angle of a triangle is equal to sum of two interior opposite angles. This is a small triangle. This is a bigger triangle. This small triangle is similar to this one. When do you say that two triangles are similar? When the angles good, when the angles in one are respectively, because these are respectively, equal to the angles in the other one. Because the angles may be in this, maybe in the other one, but the way you name the angle will not make them to be similar. When the angles in one are respectively equal to the angles in the other one. So when the angles in, if this is W, F, P. If you say W and P is similar to F FKP, this way, is similar to this way and this way. This way. You cannot say it is similar to this way. If you go the other way around, you will fail it. You understand me?
Yes.
If you say WNP is similar to FKP, WNP is not similar to KFP. Do you get what I'm saying?
Yes, sir.
Very good. Now, in similar triangle, the angles of this one are respectively equal to the angles of this. How do we achieve that? If you call this angle A, it is equal to this angle. What reason? Corresponding angle. This angle is equal to this one. What reason? Corresponding angle. This one is common to both of them. This small triangle is common to this big one and common to this, the same angle. So because this angle here is equal to this one is equal to this one is common to both of them. So the angles of this are corresponding equal to the angles of this big one. They are said to be equiangular. Equiangular. When the angles of one are respectively equal to the angles of the other one, they are said to be equiangular. So this small triangle is similar to this big one. Who will come and show me similar triangles here? Okay. Yes, good. This one is similar to this. Is there another one that is similar? Yes, come and show us. Fast. Someone has mentioned this and this. Why not this one and this small one? Sorry, you know it is smooth. It's not going to be a straight line. It's the bigger one, then this small one. So this is similar to this big one. Then this one is equally similar to this big one, to this one. This and this. Then this small one and this one. Now take reading from here. Did I put K or P before? K. Now read this value, WN, write it down. Read this value, FK, write it down. Read this value, KP, write it down. Read this value, WF, write it down. WP, write it down. FP. That is the size of the triangle. Read them. Some of you turn it that way. Turn it like this. Read this value. Read the whole value. Read the small one. Then you plug them. There is ratio. Similar triangle has ratio. In similar triangle, FP, over WP, so WN is equal to, and then this one over this one is equal to FP over WP. FP over WP. And it is equal to KP over NP. KP over NP. That's what the first thing. Now you supply the values. FK is what there?
1.4.
1.4 over WN.
5.
FP is what? Huh? 2.2 over 7 KP is what? Over KP over NP. NP is what? Do you know why I took 8.8? No. Some are saying 8.7, some are saying 8.9. So I just say, let me take 8.8. 1.4 over 5.
88.
Evaluate this one. 2 over 7.2. How can it be 3 points? 2.6 over 8.8.
0.29.
Huh? 0.30. Do you see? If you approximate this now, it's 0.3. Approximate this, 0.3. Approximate this, 0.3. It therefore verifies the similarity of this triangle. I promise you about sector of a circle.
Yes.
Okay. Sector of a circle. The length of an arc. The length of an arc. You see, this is a semicircle. This circle. Is it not?
Yes.
This sector, you can find the length of arc, SW. The length of arc, SW, it has a formula, theta over 360 times 2 pi half. Theta over 360 times 2 pi half. You cannot, if we put tape here, we can measure this. You see the essence of this material. You use Taylor's tape. You know it is flexible. You measure it and it comes here. You know the value. You keep it by the side. Then you do the calculation. From here to here, the angle is what?
9.
Very good. 90 degrees. Which is
9 over 360 times 2 pi 22 over 7 times r.
And what is the R there? And what is the value of radius there? In my own. And then when I finish my own, you do yours and tell me. What's the value of R here? Where is the radius now? Tell me the radius by using letter. E. Is it E or N? N. Or NS. So what is the value here in my own? This is here is 20, 20, 20, 20, 20. And you see that the study will be practical. Now I want you to calculate the length of SE at SE in your own. SE, calculate the length of at SE in your own. You don't need any ruler. You see there's no ruler there. And you are talking on circle. So the value, you know the radius, just put the formula. Put the formula, you look for theta, you look for phi. So what's the value you got?
15.7.
15.7. Okay. Let me reduce this, the arc. Calculate the length of sector SP. Not that too, because when the look of things, it is this one divided by 3. That is where I did not bet. You have to do it. Not you're able to say that because I have done this. Supposing I change it to say 20, it is going to further fractions. So, students, it's been a wonderful day. I will just stop with these few topics I have done with you. But I want to thank you for your patience. I want you to make use of them. Use them to learn more things in mathematics. If you have a problem, If you are connected to internet, you can send me email. When you open the box, you will see my email address here. You can send me email, I will answer you.